Now that you're familiar with soldering tools, solder types, and fluxes, let's discuss the nuts and bolts of how to hand solder through-hole components onto printed circuit boards. Most production soldering is done with automated machines that can make hundreds of solder connections all at once. But there are some heat-sensitive components that can't handle the higher temperatures during wave soldering. Defective components may also need to be removed from the board after wave soldering, and a new component hand soldered back in its place. Regardless of the reason for soldering by hand, we need to be able to make a strong physical and electrical solder connection that will last. The hand soldering process should always begin by preparing or tinning the tip of the soldering iron. We explained earlier how oxidation forms on the surfaces of the metals to be soldered. This oxidation will also form on the tip of your soldering iron. Oxidation acts as a barrier or an insulator, which means that it can slow down the transfer of heat. An oxidized tip will prevent the rapid transfer of heat into the metals to be soldered. Notice the time difference between the properly tinned tip and an oxidized tip, melting a similar solder connection. To begin the tinning process, we'll take a hot soldering iron and wipe the tip 2 or 3 times across a damp sponge. This will remove impurities and oxidation, but it shouldn't cool the tip too much. If the tip is wiped excessively, if it's gouged around in the sponge, or if the sponge is too wet, the tip could become too cold to use for soldering or tinning. Now let's apply some flux cord solder onto the tip. The flux inside the solder will flow first and chemically reduce the oxides from the tip. Then the solder will flow over the tip and form a shiny coating. This tip is now properly tinned. Tinning is especially important on brand new soldering iron tips. Every time you install a new tip, it's important to tin it right away, or it may become untinnable and unusable. Tinning should be repeated as often as necessary. Whenever you can see that the tip is no longer clean and shiny, you've waited too long to re-tin. Heat can cause soldering iron tips to become so oxidized that they become unusable. It's a good practice to melt some solder onto the tip whenever you plan to let the iron set for any length of time. This solder coating will keep oxygen from reaching the metal tip to protect it from severe oxidation. It's also a good practice to turn the iron off when it won't be used for an extended period. On some irons, oxidation can also form on the barrel, which is the area between the tip and the handle. If it's not removed, the oxidation on the barrel can also slow the transfer of heat to the tip and keep it from quickly reaching the soldering temperature. Oxidation can be removed from the barrel with fine abrasive or a wire brush. Brushing should be done away from the workstation surface to avoid contaminating your work area. After we've prepared the tip of the soldering iron, we should be ready to start the soldering operation. We'll be using a temperature-controlled soldering iron with a chisel tip. The temperature of the tip will be set at 315 degrees C. Our solder will be 6337 eutectic with a 0.5 mm diameter. The flux in the core of the solder will be type L or mildly activated. To demonstrate the basic technique, we'll be soldering a round component lead into a plated through hole. Normally, this type of soldering operation would only take a few seconds to complete, but we'll be stopping the process in order to explain everything that happens as we go along. We begin by gently placing the cleaned and tinned soldering iron tip against the lead and the land. This will transfer heat into both of these parts. Now the solder wire should quickly touch the tip of the iron to melt just enough solder and flux to form a heat bridge between the metals. Then we'll move the solder wire over to the opposite side of the joint, still touching both the lead and the land. When there's enough solder melted into the connection, the solder wire is removed, followed by the soldering iron tip. At this point, it's important to clean the connection if required. Then we'll inspect the joint to make sure it looks right. A preferred or target connection is where all of the metals are covered by solder and the outline of the lead remains visible within the solder connection. Here's what that same operation would look like at normal speed. Notice how quickly this all happens. Let's review the process once more to highlight some of the problems to avoid during hand soldering. The tip should lightly contact both parts to be soldered. Pressing down firmly with the tip will not transfer the heat faster, but it may damage the land or the base material. Only a small amount of solder should be melted against the tip of the iron. If you melt all the solder by touching it directly to the tip, you may not get enough solder to flow onto the other side of the connection. Remember that solder flows toward the heat. Flux flows away. Another problem is melting too much or too little solder into the connection. If you don't remove the solder wire at the right time, you could end up with something that looks like this. This time we remove the iron tip before the solder wire. Now we'll have to reheat the joint in order to remove the solder wire. Notice what happens when we reheat a solder joint? It doesn't look as smooth or as shiny as it was before. Now let's see what happens when you reheat a solder joint using flux. In this case, the solder appears as smooth as it did before. Whenever you melt solder, you always need to add flux, either through the core of the solder wire or with an external applicator. Now let's look at the correct technique one more time. There's a lot happening in just a few seconds. The parts to be soldered are heated, cleaned by the flux, and joined together to form a physical and electrical connection.